Um, Good morning. I'll wait for a second until. Good morning, and thank you for the invitation to speak here. Since the stage was set by the MBA program students as looking at sort of the consumer perspective, I'll start with a with some of our views on that angle. What we see today is that a lot of people position the EV as a city car. We don't really see that such a consumer market segment really exists. Because if you look at it, why would somebody be willing to give up the freedom to drive anywhere at any time when he also has the option to choose a car that does give him that option and that freedom? Now, and there may be people that hardly ever drive a distance beyond the range of what an electric battery can drive, but even those people, why would they be willing to give up that option? The what if question that was put forward in the beginning. Because we actually only see 3 reasons why some people might want to choose to have that, to not have that option anymore. The first one is because they are passionate about the environment. Another reason can be is they like new technologies. It interests them and they want to buy an electric vehicle for that reason. And the third reason why they might want to give up the convenience of being able to drive anywhere at any time is that if it could save them money. But either way, that consumer wasn't going to look for a city car or a car that was limited in range. It just decided to buy one because it wasn't too compromising when it came to his personal convenience, and it was willing to make that trade-off because he was passionate about the environment. Great, he loved the new technology angle of it, the Tesla buyers, or he saw that there was an opportunity to save costs on his transportation needs, the yellow category, I guess, that was put forward before. Now, there are 2 other things that can be said about the city car concept and electric cars. If you stack all the cars in the order of the number of kilometers that they drive, and you look at the first 25%, the ones that drive the least, they only consume 10% of the oil. If you look at the last 25%, they consume 50% of the oil. So by focusing at the first 10%, we're providing no answer to the solution. We're providing no solution to the problem that we're trying to solve, because these guys weren't the ones that were consuming the oil to begin with. And then the other thing that we can say when we look at an electric car and as a city car is, if you have a technology for which the upfront costs are fairly high and the running costs are fairly low, from an economic perspective, it makes very little sense to focus on the ones that drive a little. You want to focus on the ones that drive a lot, because the more you drive, the better your business case becomes. So if you think about the question, what should we do for an EV transition, we should probably stop thinking about the EV as a city car, because we are focusing at a market segment that we don't believe really exists. We're addressing a group of consumers that don't cause the problem that we're trying to solve, namely to get off oil, and we're looking at the wrong economics. So that's sort of as far as we see how EV should or shouldn't be positioned. Now, I understand what people think. Yeah, but range, problem, difficult, blah, blah, sure. And partially that's also the reason why some sort of retract and think, oh, maybe biofuels, maybe hydrogen, But the thing is, biofuels, I mean, forget biofuels, I think your point was valid made. The resources are no way near sufficient to cover even a small proportion of the 2,000 million tons of oil that the world consumes today. And the simple reason for that is that if you convert sunlight through photosynthesis into an energy source with an efficiency of less than 1%, and then use that energy source to convert it again through a very inefficient process to drive a car, you end up with nothing compared to what you had before. That's a pretty stupid idea. And if you have transportation needs for which liquid hydrocarbons are absolutely necessary, you know, which we can have another look at, and we make a list of those that can absolutely not do without those liquid hydrocarbons, cars are not even close to making it onto that list. So that's as far as biofuels is concerned, and then as far as hydrogen is concerned, we're trying to solve an energy problem here. The driving cost, as it is today, for the cost of transport is going to be the energy cost. Now, hydrogen costs a lot of energy to transform electricity into hydrogen and back into electricity. So, in the end of the day, that's not the most efficient way to do it, and the economics of the cost of that energy will be an important driver over time, and are less beneficial than the direct electric route. So, and the other problem is that if we want to go for hydrogen, we need a distribution infrastructure of which today we have none. And the cost of building that are basically astronomical. So let's look again at electrification, because it is the most sensible way to get off oil when looking at transport, at least for cars. Now, we need to solve three problems. It's actually two problems, but the first one is the shape of the cost. The total cost of driving an electric car, they're not very problematic, and if they are today, they won't be over 2 or 3 years with battery prices dropping as fast as they are, and with some consumers' incentives in place in a lot of markets, they already make sense today. So the problem is not the total cost, the problem is the shape of the cost. There is a disproportionate high share of that cost at the beginning from a consumer perspective. He needs to pay much more than he's used to buy the car, and then that he saves that money back over time doesn't make enough sense from his or her perspective. So we got to address the shape of the cost. The second thing we need to address is the range. People talk about range anxiety. Of course, people are anxious about the range. The car drives for what, 130, 40, 50 kilometers for the ones that we're talking about for normal people, not for the Tesla. Nobody can pay for that. Not even most people on the upper, what was it, right corner. So we got to find a solution to solve that limitation in range. And we got to do it in a way that's convenient, because otherwise consumers, they'll think again, why would I give into that convenience if I have the option to buy something which is convenient to let me go anywhere I want, anytime I want. And the third part, it's sort of linked to that range question and charging question, is the infrastructure. How do we get the energy into the cars? Now, our solution, the first step is that we say, okay, if you separate between the car and the battery, both physically as well as financially, that helps to reshape the cost of reshape the cost structure. So the consumer now pays for the car, but he doesn't pay for the battery anymore, which basically puts that car at a price which is equivalent or even lower than the car of a gasoline, the equivalent gasoline or diesel car. Now, in return for a subscription with us that the consumer takes, very much like a mobile phone contract where a number of kilometers is agreed in return for a fixed monthly fee. It's kilometers in our case instead of minutes, but the idea is the same. You get a battery in return, which you can put in your car and enables you to drive it. It's our battery, but you can use it, and it's a battery out of many in the system. Now, in addition to paying that fee, you get a charge spot at home and at work, and we provide the energy to charge your car. So that means that normally every morning you wake up, your battery is fully charged like any normal electric car, and you drive to work and back, and you charge and you drive and you charge and you drive, and it's fine. And then for that odd day that you decide to take a trip, which is longer than 130, 40, 50 kilometers, whatever the range roughly is these days, you pull in to one of the switch stations that we deploy across a market. And a switch station is, I'll show you a short video which shows you how it works, but it's like a car wash, and within, you drive your car and you don't have to do anything. Within 5 minutes you're back on the road. And because we link the battery management to the GPS navigation system in your car and to our network operation center, you don't even have to do any of those thinking. That the system will guide you through to one of those stations if that's needed, based on your driving needs. Now, what I would like to do most is to put you all in a bus, drive you to Zaventem Airport and fly you to either Tel Aviv or Copenhagen, put you in a car and let you experience it firsthand, but my boss will probably not cover that expense, so we'll have to settle for a short video instead where it's demonstrated, which is not here, but I'm sure you know how to. Right, so this is a short video which basically shows how the system works, and which is already in place in Denmark and in Israel.
The electric car is the future of transportation in a world free from dependence on oil. Better Place take that concept further and develop the battery switch model, the world's most innovative and convenient way to allow electric car drivers to travel long distances without having to take long breaks to recharge. The battery switch is informed in a network of battery switch stations, which are located at strategic spots, much like traditional gas stations. From the moment you enter the switch station, advanced robots are standing by with a fresh battery. The fully automated system developed by Better Place works simultaneously to switch your depleted battery with a fully charged one. You don't have to exit the car, and you are constantly updated along the process, which takes even less time than it took to fill up your car with gas. Drive, Switch and Go makes the electric car suitable for everyone. A car that can go anywhere conveniently and affordably.
We've got a car that's more convenient. It goes as long as you want. It's not limited by range, it's not limited by time. It's cheap to buy, it actually keeps its value. The side effects, you save the world.
Drive, Switch, Go. It's as simple as that.
Right. So, I think they got it. Thank you. So, for those that didn't get it, you should definitely visit us in Copenhagen or in Tel Aviv when you have the chance. One more thing. Unless you're going to cut me off. No, we're good?
I'm going to cut you off if you go.
One minute. The last thing, the last piece of the puzzle is how are we charging the cars? And what we do is we basically have intelligence and two-way communications with all the cars as well as with the batteries in the switch stations, so that we can time and pace the charging, and we can then look at what is the capacity on the grid, what's the availability of electricity supply, will there be a wind front coming during the night so we can take that excess renewable electricity and put that in our batteries. And because we do it that way, we actually don't need any additional infrastructure or any additional generation capacity to be installed. And that's quite a key component compared to some of the other systems such as fast charging, which actually don't utilize the grid very efficiently as it currently stands. Okay. And I'll cut myself off then. Thank you.
I need the microphone.
Right.
Okay, thank you very much. I have a question that you may answer later. That is, if your customer is Mr. Solvay that runs flat a battery of 8,000 euros, are you going to pay for the cost? But for the debate. The next speaker is Jori van Merlo from the VUB that we found out going out they bought an electric car. Maybe he will explain us why.
Thank you. Good morning. For a 10-minute presentation, I have a lot of slides. But since the session is food for thought, I thought I'd bring you a lot of food. So my slides are based on facts and figures that I had hoped there would be in the handouts. So maybe for this afternoon, because it's interesting when you have discussions to have real facts and figures. This is a slide showing you the market introduction of electric vehicles the coming years. And in a kind of red-pink color, you see new sales of electric vehicles. And you have people interpreting this slide in two different ways. You can see that electric vehicles are coming on the market, maybe 10% share in 2020, up to 50% share in 2050. And you have other people that are saying, yes, but the rest of the market is still petrol and diesel based. It's up to you how you use this slide. But what I see is that we have a lot of driving forces to go to other solutions, and one of them is just what has disappeared. That is the impact on my health, on your health in city environments. That's the impact on climate change, and one thing is still left, that's the impact on our budget. Because we are importing oil from outside Europe, outside Belgium, and we have to pay for that. If we look to climate change, then there are some, well, very hard targets we want to reach. Especially when you look to 2050, a reduction of 70% when we start from today, and we want to reduce CO2 emissions. That's quite hard to reach. And I see some other figures even going to 80%, 95% reduction of CO2. Which technology will be or will allow us to reach these low CO2 emissions? Well, this is a slide I borrowed from Mauricio, so thank you for that. Well, and he borrowed it from somebody else. So here is the source. I always mention the source in the bottom, so you can find it back. And there you see a lot of technologies in current vehicles. So in petrol and diesel engines, you introduce hybridization, you introduce biofuels, flexible fuels, etc. And then you see that we can go maybe by 2020 to 95% per kilometer. And that's quite an asymptote we are reaching. So if we want to go further down, it will not be based on petrol and diesel. If really is CO2 and climate is a target, then it will not reach with this technology. But vehicles are more than only some emissions coming out of your tailpipe. You have to produce them, and we have all learned that when you have batteries, we don't throw them away in the garbage. We need to do something with it. And a battery electric vehicle, as the name is saying, it has a lot of batteries. So what is the impact on the total life cycle of a vehicle? Well, for this, at the University in Brussels, well, with the Flemish part on the other side here, we are doing this life cycle assessment, so we include the tailpipe emissions, we include the production of electricity that you use in your vehicle, and we include the production of your vehicle itself and the disposal and recycling at the end of life. And in this analysis, you find this kind of results. So you see from here to the right all examples of electric vehicles, and from here to the left examples of petrol and diesel vehicles, compared on a climate change basis, so on CO2 equivalents. It's up to you to see who has the lowest CO2 emissions, but I think you can easily see it. If you compare it with other technologies, well, completely on the left we have again our electric vehicle, yeah, and then you see a fuel cell electric vehicle, two natural gas electric vehicles, a hybrid one. Here we have ethanol vehicles, a biofuel, LPG, and then here we have diesel and petrol in this slide. Also here you can read which has the lowest CO2 emissions. Even if we look to other technologies like CNG, the hybrid here, the LPG, they are reducing a little bit of CO2 emissions, but not that drastic as what you can do with electric ones. This one and this one, the biofuels, they are also allowing you to reduce the CO2 emissions significantly. But as mentioned before, biofuels we don't have a lot. and we will use them for other applications, I think, than in passenger cars. Okay, this is Belgium electricity. Easy to say from my side. In Belgium we have a lot of nuclear power, so we are not producing a lot of CO2 emissions when you want to burn this lighting here. So what is the impact on electricity production of the comparison of these global warming emissions? Well, here you see on your left electric vehicles. Well, it's only one and the same electric vehicle, but where the electricity is produced in different ways. And on the right you see the diesel and petrol vehicles. And you see on your left that in function of which energy source you use to produce electricity, you have different results. This is again our Belgian electricity mix. If we go to the left, using renewable energy source. And that is what we are expecting to have in the future, more and more wind energy, more solar energy to produce electricity. If we go to the right here, then we see two areas that I don't like. If you produce electricity on coal or oil, then the emissions are comparable with petrol and diesel vehicles. So that we should avoid, and what China is doing is not a good example. Okay. Last two slides with facts and figures. Total cost of ownership. It was already analyzed by the MBA students. Here you see the analysis at the University in Brussels, done by Kenneth Lebeau, sitting in the back left in this room. So if you have some questions about this figure, you can discuss with him. And so what do you see here is not only purchase price of the vehicle, also maintenance is included, electricity cost is included, fuel cost is included, and we see some numbers below zero level. So negative cost. What is negative cost? Subsidies. So we see in the Belgian situation, we see in Belgium we have some nice subsidies for electric vehicles. We have here some electric vehicles and we have here some electric vehicles, reducing the total cost of ownership of your vehicle. So if you look to the totals, this is the same graph, but only I show you the totals. And then we see the market here of the smaller city cars. If you compare them with a C1 Citroën, for instance, they are more expensive. Small city cars, electric ones, are on a total cost of ownership basis more expensive. But if you look to this segment, Volkswagen Golf type of vehicles, where you find the Fluence and the Leaf, they are quite, well, comparable already with conventional technologies. This is total cost of ownership. We have to charge the batteries. Well, one of the possibilities is in the middle on the top, which is inductive charging. On the right, which is battery swapping. In the middle and the bottom is fast charging. And then we have the conventional charging infrastructure we do at home, at our campus, so you can come and charge your vehicle too. What we will have in the future, battery swapping, inductive charging, fast charging, I don't know. I think we will have a lot of solutions coming together to help us charge our battery. But what I do know is where our vehicle is standing. In this graph you see 1 week, and in green the vehicle is standing at home. In red the vehicle is also not driving but standing at your workplace. And only in blue the vehicle is driving, and that's a little bit difficult to charge. Instead, when you have inductive charging system, then you can charge while driving. But so a lot of green and a lot of red, so two places where we easily can charge our vehicle while it's doing nothing. So then you have to find the locations. You can use the website of the Belgian Association of Electric, Hybrid and Fuel Cell Vehicles, and there you find your charging locations, which is also available on your smartphone. And the Belgian section of electric and hybrid vehicles makes part of the European network, which is presented here. So you see different European countries very active in the field of electric and hybrid vehicles. And behind these associations you have the car industry, you have the electricity sectors, you have research institutes which are members of this large network. And by this I conclude my presentation. Thank you for your attention.
Oops, lost this thing. Thank you for sharing a lot of good data. I mean, some of that was mentioned, but it's nice to see it on the graph. Now we have Bruno that will talk to us about network issues.
Thank you. I'm not sure I will speak on network issues. There's a slide. Sorry. Okay. Yeah. So yeah, I'm Bruno van Zeerbroek. I'm actually working in the renewable energy sector, but what I will tell is I will rather tell things based on my experience in the mobility sector. I've been working in research in mobility during 7 years. So I would rather give us perspective from that point of view. And the point I want to make is we are thinking about electric mobility. It's a new kind of mobility. We will go to a new kind of mobility. When we think about it, I think it's important that we will maximize the added value for society of this transition to electric mobility. And there are 4 dimensions on which a mobility system, or at least 4 dimensions on which a mobility system can provide added value, or 4 dimensions on which the mobility system can give added value to society. So that's the efficiency of the system, the health of the citizens, the well-being of the citizens, and the congestion of the mobility system, of course. So for the 4 systems, for those 4 dimensions, I will set the scene and then give an idea on how we could design our mobility system to get the positive effects. The first element is efficiency. We really need to make our systems much more efficient. So the challenge is, on the left-hand side, I put a graph with our ecological footprint. So a kind of indicator of the space we need to sustain our consumption. So I guess everybody knows the concept. A sustainable ecological footprint should be 2.1. So we can use 2.1 hectares to sustain our consumption, on average on the Earth. Actually, in the world, we are on an average of 2.7. In Europe, we are at nearly 5. In the States, they are at nearly 7. So, yeah, we really need to do better. What's the evolution? So I found 2 graphs indicating the graph above on the resource extraction, how many resources we extract, and the message is clear. We're extracting more and more resources. Although we get more efficient, our GDP is growing faster than our extraction of resources, but we still are extracting more resources, more and more resources. The same story for energy. We're getting more energy efficient, but we still use more and more energy. So how can we help to get more efficient, or what do we need? I think we need, for sure, electric vehicles, but I think we need even to go a step further and really think about the light electric vehicles. And in the table, I give some examples of the energy use of different kind of vehicles. So not only cars, but vehicles. So the first one is a conventional car. Yeah, it's a conventional car. So if we look at the relative energy use, if we put it at 30, an electric car is much more efficient in general, as Yuri showed us very well. We can gain 20–30%. But if we make this car much lighter, we limit the speed somewhat, then we can even go to 10. We can divide it by a factor of 3. If we make it still what lighter and smaller, a one-person vehicle, we can divide it by a factor of 10. And then I give also the example of an electric-assisted vehicle, an electric-assisted bicycle. Then we can even make it 30 times more efficient than a conventional car, or 20 times more efficient than an electric car. So I think that's the first thing we need. We need efficiency. We need really much more efficiency than we have actually. So we should think about light electric vehicles. And of course, for mass transport, the last sentence, for mass transport, we should still have, or for the bigger flows, we should still use mass transport, of course. The second point is health. We are probably not aware of it, but physical inactivity has a huge social cost. So I found some figures on the website of the World Health Organization. So up to 1% of GDP is the cost of physical inactivity. And the evolution is not going in, we are not getting more active, but in general people are getting less active. So if a mobility system can also help to improve this dimension by promoting active transport modes, and we can make our electric vehicles human power assisted. And this vehicle assist, as I already told you, these are electric bicycles, and they are a huge success. They're really successful. I think these are the vehicles, the electric vehicles that are mostly sold in the world. So efficiency, health enhancing. Here another one is well-being. There's also somewhat complicated. First one, what's the challenge and what's the evolution? Here is a small graph. The upper line gives the evolution of GDP. GDP is increasing since after the Second World Wars. In our Western economies in general, GDP is increased. But the happiness feeling, so the well-being feeling of people, it remains stable. So we're getting richer. We're always moving faster around. We're moving more goods around. But we're not getting happier in general. From service, we're not getting happier. What is making us happy? So what is very important are family, social contacts, the link, possibility to get relations, to speak to people, having contacts with people, and equality. And then there are also some other things, but I think the two first elements, the mobility system can probably give us some help to make it easier to have those contacts to get equality. So I think an important point here is to have the livable cities with a silent, clean atmosphere where electric vehicles can help us, but also open spaces where it's nice to live, nice to come. So not to use too much space for mobility ends. To put the cars, we should, if possible, use only very little vehicles. Therefore. Eventually shared vehicles. If we share the vehicles, they will take even less place. Second element there is also affordable mobility. So again, equal access to mobility. The mobility should be affordable. No status mobility, and here again, shared mobility can help. Therefore, so what I told is we need electric and shared mobility. Small vehicles for the individual transport, combined with a mass transport for the bigger flows. And probably speed is not an absolute necessity. Getting faster everywhere is maybe not what will make us happier, or what will improve the well-being of people, of our citizens. So first point, efficiency. Second point, health improving. Third point, well-being improving. 4th point, congestion decreasing. This will certainly not be a secret, but we know a lot of congestion. We have a lot of congestion in Europe. Estimates go to up to 1% of GDP should be the cost of congestion. Congestion is most of the time not decreasing, maybe with the exception of financial crisis. So what do we need? Or what should we think about, or how should we design our mobility system to decrease also the congestion? The first thing is, of course, that's not a change, that's not a new thing. For mass transport, we need mass transport for the big flows. And then for the smaller flows, we can use once again those light electric vehicles. This individual transport can bring us to the nodes, to the intermodal nodes where we take the mass transport, or they can bring us directly to the place we need to be. Because of course it's not always interesting to go first to an intermodal node and then go to your destination with the train or the bus. I think that the road charging system can help, can give the right incentives. If you design your road charging system correctly, so you pay per kilometer, you can give the right incentives to use one or another, means of transport. Another important thing is with your road charging system, you can also compensate for the tax you lose, or the state loses, because on electricity up to now there is no tax, or only a very minor level of taxes. So to summarize, it's important to get the maximal added value for society, and therefore I propose to have a mobility system, or electric mobility system, that is where sharing is important, some human powered assistance, light electric vehicles, intermodality, and so we could name it, if we take the first letters of the different words, we come at Šupa Levi. So that's my point. Thank you.